Human night vision actually does exist, but not all humans would agree. That is because at the onset of darkness, we are always the first to stumble upon furniture while our cats paraded regally around the house, seemingly unperturbed. It may not occur instantly, but night vision in humans is not a myth and is definitely not reserved for comic book heroes alone. We may not fare well when compared with night predators, but our eyes can rival those of owls and cats close enough. Only, it doesn't come just as quickly for us as it does with animals. Human eyes need about 20 to 30 minutes to adjust to darkness and make use of their natural night vision abilities. Popular theory has it that while the cones of the eyes work at levels of high illumination, the rods take care of vision under levels of low, dim illumination. The type of vision that is provided by the rods of the eyes is known as the scotopic vision. It produces images of poor quality and can only differentiate between black and white, but are believed to be responsible of human night vision. The dimmest condition in which the rods of the eyes can function and produce images in the dark is on an overcast, moonless night. Both the rod and the cone function dually, allowing the human eye to be sensitive enough to adjust efficiently between changes in illumination by as much as 1 million times. So, why does it take long for humans to adjust to darkness and take advantage of human night vision? It is because it takes about 30 minutes, sometimes even less, for the retinal and opsin molecules in the rods of the eyes to merge into a chemical known as rhodopsin or visual purple. This chemical is primarily responsible for night vision in humans as they enable the eyes to pick up the whites from the blacks better. They are, however, very sensitive to light and tend to separate into retinal and opsin molecules when exposed to high levels of illumination. When confronted by darkness, these molecules naturally recombine together into rhodopsin to let the human eyes see in the dark. This process takes quite a while, though. There is, however, a light adaptive mechanism that comes instantaneously as opposed to the chemical changes involved in photoreceptors mentioned above. Neural adaptation can also make human night vision possible. This light adaptive mechanism happens in the retina and is generated by retinal neurons as a response to changes in the neural gain. This mechanism incites about 100 rods or more to merge into a single nerve fiber within the retina and thus improve night vision ability by about 10%. This conjugation of rods would then transmit a light signal to the brain, which would then form an image in the dark based on the patterns of light the rods have collected.